Hello again and welcome to part 18. So in this part we will learn how to apply the integral mean value theorem for calculating or estimating the value of integration. So in this part we will learn how to estimate the value of integration between, so we will find it's between what and what values. Okay, so in here the point is, or the point from using the integral mean value theorem, to intercept the value of the integration between two values. Okay, so let me tell you how to do that. So in here we can say that this. Okay, so in here, for example, we have our questions, which is the question is. So in exercises 29 to 32, use the integral mean value theorem to estimate the value of integral. So we will use the integral mean value theorem for estimating the value of integration. So let's see how to do that. Now, the integral mean value theorem, it says that if you have the integration from a to b of f of x, okay, dx. Now you can intercept the value of the function. Okay, so in here you can say, for example, f of a, if it's increasing function, less than or equal f of x less than or equal f of b. Okay, then after that you can say that this is equal to the integration, or this is the same if we find the integration from a to b, from a to b, the integration from a to b over here. Okay, so that will be equal to f of a multiplied by b minus a less than or equal the integration from a to b of f of x dx less than or equal the integration, or this is just the value. So this is f of b multiplied by b minus a. Now this is if the function is increasing. Now if the function is increasing, it will be, or if the function is increasing, if the function is decreasing, okay, it will be the opposite. The same rule exactly, but it will be the opposite. So I'll put f of b over here and f of a over here. Okay, so how to do that? How to apply this rule? We will see by solving a question. So in here, the steps for applying this rule. Question 30. Let's say we have question 30. Okay, so we have the integration from 0 to 1 over 2 of e to the power minus x squared. So first of all, I have to find f of 0 and f of 1 over 2. Okay, so I will go directly and find the values for f of 0 and f of 1 over 2. So over here I need the calculator. So the function is e, so alpha e to the power minus x squared, right? So I will calculate at 0. This is going to be equal to 1. Okay, so the first one is 1. What about 0.5, which is 1 over 2, the same? So this is 0.778. So this is 1 and this is 0.778. So obviously this value is greater than this value. So this part, it will be on the left, okay, which is the lowest value, and this is the highest value. So in here I will say f of 1 over 2. So I will start with the lowest value, less than or equal, okay, f of x less than or equal f of 0. Okay, now after that I'll find the integration for all the parts. So f of 1 over 2, we already found this, okay, which is e to the power minus 0.5 square, okay, less than, for sure we need the integration also, the integration from 0 to 1 over 2, okay, less than or equal the integration from 0 to 1 over 2 of f of x dx, less than or equal f of 0 or the integration from 0 to 1 over 2 of f of 0. So this is going to be equal to e to the power minus 0.5 square, okay, multiplied by 1 over 2 minus 0, okay, which is 1 over 2, then less than or equal the integration from 0 to 1 over 2 of f of x, which is e to the power minus x squared dx, less than or equal, this is f of 0, which is 1, multiplied by 1 over 2 minus 0, which is 1 over 2. So this is 0.5. So let's find the value of this expression. So in here, I will say e to the power 0.5 square, which is equal to 0.778. So multiplied by 0.5. So this is 0.389. So this is 0.389 less than or equal the integration from 0 to 1 over 2 e to the power minus x squared dx less than or equal 0.5. So in here I can know that the value, okay, the estimated value for this integration, it will be between 0.389 and 0.5. So let's find the accurate value for this integration just to make sure that our answer is correct. So in here 0 and in here 0.5, and the function is e to the power minus x squared. So this is equal to what? 0.461, which means it's between 0.389 and 0.5. That's it. Okay, so this is how you can solve the question using the integral mean value theorem. The same thing, but you have to be careful. First of all, start by finding f of a and f of b. The one or the lowest, I'll put it at the first, and the highest, I'll put it at the end. Okay, so maybe sometimes the 0 or the first value or this value, it will be the lowest sometimes, and sometimes it will be the highest. That depends on the type of the function or the part of the function that you are graphing, if it's increasing or decreasing. Okay, so just find them. The lowest I'll put it over here, and the highest I'll put it over here. Then find the integration for all the parts. Then that's it. You have your answer. Okay, so now let's move to the next part, which is in here exercises 33 and 34. Find the value of C that satisfies the conclusion of the integral mean value theorem. This inclusion or conclusion is the F average, which is 1 over b minus a, okay, multiplied by the integral from a to b of f of x dx. So first of all, to solve this question, you have to find f average, okay, which is by using this rule. Then after that, the second step, find f of c. So you have to substitute c in the function. Instead of each x, I'll put c. Then 3 f of c, make it equal to f average. Then the fourth step, find c. And it has to be between A and okay, so let's see how we can solve this question. So directly, these are the steps for solving the question. So in here, let's say if we have a question 34, for example. Okay, so first of all, I have to find f average. So f average, this is equal to what? 1 over b minus a. So in here a, in here b. So 1, which is b, minus 1, multiplied by the integration from -1 to 1 of x squared minus 2x dx. Okay, now they are saying that the value of the integration is equal to 2 over 3. So I will use it. So in here, 1 over 1 minus minus, which is 1 over 2, multiplied by 2 over 3 from this question. So in here, this is going to be equal to 2 over 6, which is equal to 1 over. Okay, now we have found f average. Now we need to find f of c. F of c, you have to substitute c only. So this is c squared minus 2c. Now make f of c equal to f average. So c squared minus 2c is equal to 1 over 3. Now, all I have to do is just finding the value of c. So c squared minus 2c minus 1 over 3 equals 0. Then I'll factorize this. So in here, I'll go to menu, then a. I have polynomial from the second degree. The first one is 1, then minus 2, then minus 1. Okay, so that's it. This is the first value, which is 2.15. Yeah, 2.15. And what about the second value? So this is minus 0.154. So minus 0.154. I'll find which value is between these two values, between -1 and 1. Of course, 2.15 is not between them, but I will take the minus 0.154 because it's between them. So that's it. This is my answer for this question. So this is how we can use the integral mean value theorem in the first part, and how to find the value C that satisfies the conclusion of the integral mean value theorem. So next, inshallah, we'll move straight forward to part 90. So see you then.